So you've done a little bit of practice here. These little rectangles were originally very, very tiny up on the top left. So you can, if you get stuck, you can just expand them like that. But it looks like you got the hang of them when you did it on your own. That you've got all the questions right. The only thing that you were unsure of is, I mean, you did simplify them as well. But what we should do is only write the simplified fraction. The simplified fraction, this one here, is the final answer. It's true to say that it's 10 over 12 or 5 over 6, but only 5 over 6 is the simplified fraction. So that should be the one that is written on the dotted line. But you basically you've got it right. You remembered the method, or perhaps you might possibly have watched one of my videos. But either way, you applied the method correctly. So we are looking to see a number that 4 and 12 go into. Well, 12 obviously goes into 12, and actually 4 goes into 12 too. So we only need to change one of the fractions. 3 over 4 becomes 9 over 12. What we're asking is, what did I need to multiply the 4 by to get to 12? I need to multiply it by 3. And so I have to also multiply the 3 by 3, giving me 9. And now I've got the same denominator. I keep that denominator for that bit there, and I just add the two numerators. It gives me 10 over 12. And I can simplify it because both numbers can be divided by something. They can both be divided by 2. So the answer, the simplified fraction, is 5 over 6. Same sort of idea down here. Oh, actually, number 2 is a little bit different, actually, because we have to change both denominators. We need a number that, just like before, we need a number that 4 and 12 goes into. Well, the answer was 12. But this time we need a number that 5 and 7 go into. We need a brand new number for both of them. So 35, they both go into. How do I know that they both go into it? Because what I do is I just multiply 5 times 7, I get 35. And so I've got a number that they both go into. So now what I do is I make that the new denominator for both fractions. I ask the same question: what did I multiply the 5 by to get to 35? Multiply it by 7, because that's how I got the 35 in the first place. So I multiply the top number by 7, and I repeat the same process with the second fraction. Question 3 is like question 1, in that we are keeping the 5 over 6 the same and changing that to 3 over 6. I've added an intermediate step. You don't need to do this, but this is just something helpful because it's going to be useful for when we do other topics. So before, we just missed out that little bit there, and we just added the two numerators, got 2 over 6, and we simplified it. But with this one, what I've done is this intermediate step. I said that's the same as 5 minus 3 over 6. So that's just a nice little intermediate step to be aware of. And you can do it in your head. You don't have to write it down. You don't have to write any of these things down. You just need to write down the final answer. But it's just good to write your working out if it helps you to make sure you don't make any mistakes. And also, if you get the wrong answer, you can get some of the marks that are working out. So anyway, so these are just more of the same. I've started to reduce some of the support, so I started to reduce these arrows and got you to kind of work it out before I drew the arrows, and you're getting the hang of that. Now this last one, it asks you to do it as a mixed number. So you've not done it as a mixed number, you've done it as what we call a top-heavy fraction. So you'd get the first mark but not the second mark. Now, a mixed number is when we say is something like this: 1 and 2 fifths, 2 and a half, 4 and a third, whatever. And essentially, if the number is greater than 1, then we really want to be, well, we can't write it as a mixed number if it's not greater than 1, but if it's greater than 1, then we can write it as a mixed number. We know if it's greater than 1 if the numerator is larger than the denominator, because if it was exactly the same as the denominator, like 30, let's try to write that again, 33 over 33, for example, that would be 1. We know that 33 divided by 33 is 1. Or another way to think about it is if we had an object like this. I always tend to draw these rectangles. Imagine chopping this up into 33 bits, and so that's the denominator is like how much I've chopped it up into, and then so I've got 33 little, and then this is how many of the bits I'm going to be talking about. So I'm talking about all 33 bits. I'm talking about the whole thing. So it's one thing, as opposed to half of it or 1/33 of it. So this is more than 33 over 33, which means it's more than 1. And what I can do is I can use the chunking method again, and I can say that, well, 43 over 33, well, it's the same as 40 over 33 plus 3 over 33, right? That's just chunking it. Not very usefully, though. I can't really do much of that. What I want to do is make one of the chunks to be the same as 33 over 33, because I know that that is 1. So 43 over 33 is the same as 33 over 33. And then how many more 33s are left? 13. Oh, no, not 13. 10. 10 over 33. Well, and as I said a moment ago, 33 over 33 is, of course, 1. So it's going to be 1 plus 10 over 33, which is just the same as 1 and 10 over 33. So that's the answer that they were looking for, okay? That's how to separate it into these mixed numbers. So that's the kind of thing we're going to be practicing next time. And we're also going to be going backwards. So taking the mixed numbers and separating it into top-heavy fractions. Like this is a top-heavy fraction. Now we call it top-heavy because the top is larger than the bottom, okay? Okay, right, I'll just save the video there.